Hello and welcome back to Electronics with Emrys. This is the final video in my Building Your Own 9-volt Battery Tester series. I tried to leave in all of my layout decisions, so it's a pretty lengthy video with a lot of me talking to myself as I work my way through the layout. You'll see that I changed my mind on a few things as I went, which I think is pretty normal in a board layout. I decided to just leave in my original voiceover even though I had some background noise in it, so I do apologize for not re-recording that for you, but at least the entire layout is here for you to see if you're interested in going through the entire process with me. This first part ends up getting redone a bit later, so I'm going to breeze over a lot of it. My first job was to get the components physically placed where I wanted them. I decided to have the LEDs across the top of the board and the measurement point at the bottom right, which will be the two main user interaction points. This means that if you hold the board in your left hand and a battery in your right, it should be pretty easy to see the results and the reverse battery indicator. This is mostly aesthetic, but keeping connected components close together will certainly make your layout go a lot easier. You'll see that I end up rearranging the channels in the comparators to make my layout easier, which is a fairly common thing to do in a layout with multiple channel ICs. I don't like that this isn't centered properly. I mean, my logo is okay in the corner over here. I think the battery tester connection is going to go to the opposite corner and have a similar spacing. So it's about 200 mil or maybe 150 mil from the edge. And then this reverse LED, I would like to have that show up somewhere maybe closer to the middle. Let's see if that's pretty close. So I found a quick way to measure the middle is just to draw a line and see, because I know this is 3500, so 1700 would be about half. And that's exactly half because there's two dots there, so 1700 on this side, 1700 on the other side. So could escape a couple times to get out of there. Great. So now I've got all the footprints the way I want them. I've got everything set up the way I'd like. I think the one thing I'm not going to route is going to be ground, and that's because ground is going to be connected on the back plane of this. I will most likely connect up on the front plane either the positive 5 volts or ground or something like that. I haven't 100% decided yet, but there's plus 5 volts there. Over here is plus 5 volts also. All of these are connected with plus 5 volts, so it's going to be a good idea to at least run a line down there. I'm not too worried about that though right now. One really important thing to remember about this particular board is that everything is DC, so we are not concerned at all about the speed of signals on here. So we can really run traces any way we want as long as they're able to carry the current we need, considering that we're only looking at up to 100 milliamps, and that's only going to be on one component. So the LP2950, that's my regulator, is going to be pushing up to 100 milliamps. That's because it's going to be driving all of the components on the board, including a bunch of 10 milliamp LEDs. But if we add up all that, it's still not that much current. So I can probably run 8 mil traces all over this without any issues at all. I'll probably make them a bit fatter than that because this is intended as a beginner board. I want to make it more robust so that whenever people solder it, they have less chance of damaging the traces. But whenever we need to squeeze into places, I don't have any problem going with smaller trace sizes. Now, I would like to put these sizes on the board because this is something that's going to be necessary for you as you're building to be able to put these in. That says it's visible, but this is the fabrication layer, right? So I think what we're going to do is we're just going to add, for one, we're going to switch to a 25 mil grid. And then two, we're going to add text, and we're going to be doing that on the silkscreen layer. Front silkscreen, we're going to add some text. And this is going to be 174 for the first one. And we will adjust the size of this, but that appears to be about the right size. I also want this to be centered properly, so I'm going to just place it right there. And then I'll double click on that and change it to be centered. And it's going to be aligned to the bottom. The size of that being 40 mil high. I think that's going to be fine. I don't have any problem with that. We don't need this text to be super large or anything. And I think what I'm actually going to do is I'll start with it over here, and I'm going to move them all to the right at the same time because it's all going to overlap. But I don't know, maybe we'll just do this. I think that's okay. We'll just slide the assembly text over to the side because it doesn't have to be right in the middle there. It's fine. It's not like you're actually going to be using the assembly text on this board anyways. Let's do that. And this guy, we're just going to copy paste. And then this one is going to be 88.7. Paste in another, that's 102. Paste in another. Oh, wait, I'm going to move this guy over. I think actually here I'm going to do myself the favor of selecting all those and just moving them over all at once. And then maybe one tick to the left. There we go. We're going to put one right here. That's going to be 1500. That's 100K. And that's going to be 220K. Hit OK. So each resistor has the value directly above it. That should be relatively easy for somebody to read. But honestly, I think I like it underneath. I think I prefer it underneath the resistor, like that. That just reads better. You have R6 with 174 ohms. Should be pretty easy to figure out either way, but... Okay, so I'm just going to pull these over here. 63.4. Bring that over there. This guy's 113. 100. 115 is going to go there. And 680 is going to go there. So then we're going to just paste in 174. That's 1740 over here. And then here's going to be 63.4. 100. 113. I have a bad habit of pressing enter after I place in one of these. Okay. And 680. Okay. Then we're going to be going ahead with a couple of other things. So this C4, I want to rotate that and place it above, mostly just because I want to make this match up to the other designators. It doesn't have to be above. And then down here, I'm going to call that 0.1 micro. Okay. And we can about line those up. It's fine by me. And we'll do the same thing right here. We're just going to bring that up there, bring this down here, and we're going to paste this right there. Okay, 0.1 micro. Now along the top here, I think, now I expect if somebody's holding this right-handed, they would be holding it with this on the right side. That's across the left side. So really, realistically, I want people to hold it facing up like this, but of course you can hold it any way you want. Okay. Yep, U1 and U2 are perfectly fine the way they are. U3 is fine. I'm just going to drag this guy down a tiny bit to be able to place in a size there, because I do want a size here. Oof, and that doesn't want to center. So what I'm going to do is go ahead and switch to my 12.5 mil that I made last time. There he is. There we go. It's fine by me. 2.2 micro. Okay. And we're going to just do the same thing again. 2.2 micro. Okay. I think I like these guys being pulled into the middle of the board a little bit. Maybe we'll pull these into the middle of the board a little bit. This guy is intended to be with U3, so we want him to be relatively close to that. Preferably, actually, I'd like it to be fairly close to that. We're going to take this, rotate that. How close do we have him up there? That's 1 grid square, definitely, plus little. We're going to have 1 grid square, definitely, plus little. Should be fine. C2. This guy is going to go down here. And we're going to do that. And that's going to be a 0.1 microfarad. Okay. Q2 doesn't have any, capacitors on him. D11, D9. Yep. So I think that's going to be fine. I think we're going to bring that over from the edge. I think I'm just going to label that there, 9-volt tester. Seems pretty good to me. Right about there. All right, so the general layout, the general text is pretty good. I do want to add these so we can see the values up here. So we're going to put in a rotate that, and that guy is going to be 287. So we're going to do 287. Okay, then we're going to copy that, and I'm just going to paste him in here across all of these. Makes sense, considering they're all the same value, except for these that are 162. Okay. There we go. That's pretty good. There we go. Now we're going to go to the top layer. We're going to start routing. We've got our routing tool. And I want to go up here into my routing tool options. Don't need the properties manager. Okay, predefined sizes. So our track has all these different sizes. I think we're going to add a track size, and it's going to be a, let's call it a 24 mil track. We're going to add an 8 mil track. We'll add a 10 mil track and a 12 mil track. Okay. And switch to 24 mil to start. Actually, let's go to 10 mil and see how this goes. So we do have a whole bunch of measurement connections going on around here. And we are going to have, from here, that's going to come into there. Let's see what we need to do here. So my plan, we're just going to connect together these. Press R, no, undo that. We're going to get into the routing tool, which is X. Okay, yeah, X for the routing tool. And we're going to connect these two together. But I want these to be quite a bit beefier. So what we're going to do is make these 24s. We're just going to connect U to U, U to U, U to U. And then we're going to route from here to here, from here to here, and from here to there, here to there. Okay. Now that is going to come down to, we're going to come over to here. Basically, we're coming out that way, and then we're going to come out this way, and we do want that to be like that. Okay. Now we've got a few different things we're going to have to do here. So this guy is going to have to run all the way around to the other side like that. So now that's getting really close to stuff. I don't like how close that's getting. So here, check how close that is. What's that gap? What is it, 5 mil? A 10 mil gap? Oh, okay. Yeah, it's not that close. It's not that bad. Okay. So then we're going to take this. We got the 5 volt. I'm going to ignore for now. This right here, we've already connected. This guy, on the other hand, needs to connect to here. Okay, and this guy probably going to come around all the way to there. I think we might come all the way around like that, all the way around, doing that, all the way around like this, like that. And that guy, I can see how people end up with those messed up. We're going to go ahead and connect this to here because I want a direct connection between those. This, yeah, I'm going to get rid of that. You need to be pulled down to in line with my buddy there. I want those in line with each other. That's going to be connecting straight across, just like that, plus 5 volts. Great. Ground goes to ground, that's fine. Out 90, out 50. Okay, so these, see, I actually don't like this going here. We're probably going to reroute that right there. That's okay. Let's check out how we're going to be connecting these. So we're going to be connecting that from here to there, 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 and here to there. Then this guy, that's all 5 volts. I'm not going to worry about that just yet. We've got these 4 over here that are going to be connecting across to, there's 1. And you can see how that hooks up. 2 is going to be coming around this way, like this, coming around like this to there. And then we're going to have 3. Now this guy is a problem, right? Now this, there's no easy way to come around and do this, but we can do that. We can come around and do this, and that goes to there. And that's not a major issue, right? So those are our 4 connections to these LEDs. Now, if you notice, this one kind of needs to go this way. There's not an easy way to go any other way. So probably for the 5 volts across, probably on the back of the board for most of these, or maybe just this connection right here. We'll see how that goes. Okay, well, I'm going to work on just getting these generally laid down, and we will come back and try to get them figured out later. So this guy's going to come around like this, all the way around to there. This one, no. So where's that guy going to go? So this guy is going to come out this way and up to there, over to there. And that one is going to come down to here. Okay. So far we've got all that. Now this one, we do want to have this guy. We got him lined up exactly like the other one, right? We want them lined up. Yeah, that needs to come down 1 tick maybe. See how that lines up. It's pretty good. All right, we're going to just hit X here. Connect straight across. Yep, great. This guy, we're going to run X up this way. And, whew, look at all that. We're going to come around like this, up there, around that way, all the way down to here, and then across like that. And we're going to come across kind of like that. Let's see if we can get this guy to, maybe we can get him to delete all that out. No, it's not going to delete. Yeah, KiCAD's not as smart as Circuit Maker or Altium, but is free. Okay, and we're just going to hit X, bring that across to there. There we go. We'll see about getting all that fixed up a little bit. I don't really like the way all these tracks look, but they're not bad. They're connected. We're going to go ahead and route across. There's our V measurement. So let's do this guy. Gonna run that up to there. That V measurement. No, I don't want him yet. Okay, so now are we gonna run in between here? Yeah, that's gonna be fine. And I think I prefer to go into that electrical connection there. We're gonna go ahead and see that that is a ground. That's a ground. V measurement. Okay, so we got V measurement. V measurement. Okay, great. So now I have these V measurements that are going to be connected up, but let's get to this guy next. Yeah. I think we're going to be coming around like this, all the way around you, my friend. Kind of like that. That guy is going to be coming around similarly. Oof. Yeah, that's not, there's no way out of there. There's no good way out of there. Okay, so I don't really like the way that came out. So let's take that guy over there. We're gonna do, hey, let's do this. Let's grab that up like that. This guy's gonna come up to here. Come over there, and we're gonna hit X to there. Perfect. Okay, so that's much better than what it was. But this guy right here, whenever we grab him, he doesn't have any way to get over to here. So that's a problem, right? But that's not a big problem. Let's not worry about that just yet. And actually, you know what? I don't really like this one going this way either. So we're going to just ignore him for a minute. Let's hook up all of our V measurements. So this guy is going to get routed across to the center here. And again, remember, these are DC signals. So this is not something I'm worried about reflections or signal integrity on. So we're just going to run in from each of these to this central bus line. Okay. And then we're going to be connecting right here to this. Think right like that, and then basically straight up. We're going to be grabbing that, just drag him over a tick. Yep. And this guy. There we go, that's pretty good. All right, so I kind of like the way that ended up. We're going to be doing the same thing over here. Let's get rid of this guy that kind of has to run a little circuit around there. I'm going to do the exact same thing over here. So we're going to run to the center of this chip. And same thing here, right like that. We're just going to run straight down to there. Okay, and then V measurement here, V measurement there. Okay, and now we've got all of these different V measurements going where they're supposed to go. Okay? Not a bad way to do things. Alrighty. So now there's a lot of stuff going through this central point here. Seems unnecessary considering this line right here. So, but that's coming around that way, right? So that is going to here when it doesn't really have to go that way. So let's do this, then this guy right here. I think we're going to just take that and we're going to hit X on that. We're going to bring it up and out this way and then back down along here, and it's going to be like that. Rerouted much better now. This guy does have to kind of go that way, and this guy basically does have to go that way as well. This guy, on the other hand, is pretty much stuck there, but we can bring them in a lot closer to these to open up this central area. I'm going to just bring that in there. Okay, so we've got all that. This guy kind of has to route around the inside to get to here, which is actually probably the best way to go. Just because this is not going to be able to come out here, most likely. This guy has to go around here to there. And I mean, realistically, you could shuffle around the... Oh, you know what we should do? We should shuffle these around. We should do that. After doing a bit of the routing, I've decided that I don't really like the way that the outputs here are lining up with the LEDs. So what I'm going to do is rearrange this so that the output for the 25p here is not going all the way off to the left and then back off to the right, where I could just pick this to be the fourth channel, and that fourth channel will just come up this way. Or sorry, that's not 4. That's out pin 13. I don't know which one that is off the top of my head. But if we have that fourth pin right there, go up there, and then this pin go to here, this pin go to there, and that pin come back over to here, that would be much cleaner. And there's really no reason not to do that. It'll clean up everything. So I'm going to go ahead and rearrange this. So we're going to have pins 1 and 2 are going to be 2 and 5%. So let's go ahead and go over to the schematic. And you'll be able to see this is pretty easy to do. In the schematic, all you got to do is look at the chip here. And we see that pin 1 is outputting to 90 on this one. Sorry, let's go to the second one that I was working on first. But 2% is all the way on the left. So I want that to be pin 1. So we're just going to take this guy right here, and we're going to paste him right over here. And I want that to be this one. So then we're going to take out that one right there. I'm actually going to just go ahead and rearrange all 4 of these, so that'll just make my life easier. So that 14 comes down here, 13 goes up there, and then 2 comes down here. 2 is, yes, and 1 goes up here. So that should be good. We're going to hit save, update our PCB, update that, close her out. We got our 2 new placements there to make them look nice. U1 gets drugged down there, U2 gets drugged down there, and this time make sure U1 is on the right, U2 is on the left. Okay, U1 on the right, U2 on the left. All right, so now we should be good to go. I'm going to go ahead and place in a track right here that's going to run off to the left, and that track goes right there. Now you can see that goofy kink that you get in there. If you just left click right here and then drag down, you can see that it automatically deletes the kink and fixes it for you. So that's one of the cooler features that they've added to KiCAD. Then we're going to come up here, we're going to do basically the same thing, coming across here and right into that. That one came out okay. This one, I'm going to just run over the top and over this way because that's going to be coming down with the other one. We'll just come along like that. And then this one, I guess we could have run these the other way around. I don't think it really matters all that much. Yeah, you know, I think I prefer you coming out to, yeah, a little bit like that. I think I prefer that, but remember, you're on a DC board. All these little kinks and bends are not going to do a darn thing. And even in a reasonably high signal board, you know, hundreds of megahertz, this wouldn't cause much of an issue. It's only when you get into the high megahertz and gigahertz where you got to worry about having really well-formed traces. Let's see. So with this thing, looks like he's pretty good. I think I'm going to just go ahead and replace that little section there. All right, so then this guy is going to come around to there. This guy is going to go up to there. This one comes up to here, and this one goes up to there. So we have, I'm going to go ahead and just bring this out a little bit so it's not as, not as direct there. It looks a little nicer. Doesn't need to be perfect here, just making it a little different the way I like it looking. This one, you don't want to have these little acute angles here, so usually we'll just run away from the pad a little bit and then up to there. We could also just run this straight up all the way to there. I mean, that's not a problem either. Either way would be perfectly fine. I'm kind of tempted to run this track straight up and then bring it around, but whatever. Doesn't really matter. There's not anything else going in this direction actually, so we could do like this and then come across to there. This guy could come up probably like that. It's not bad. Now we've got our net here that has to go all the way to the other side here. That's going to be a slight problem, but not a major problem. This guy. Now these two right here, I would like to have hooked up like that. That's going to come down to there. That goes to ground. That goes to ground. Plus 5 volts. Okay. All right, well, let's try to get these routed. So from here, that's the first connection that's not going anywhere yet. Pin number 5. That guy's actually going to end up coming straight around here and straight to there. And that's perfectly fine with me. That little T is not going to cause any issues at all. What you can do if you're paranoid about this kind of thing. So for one, we can move this down to have it better reflect, be in between these two resistors, just to look nicer. The other thing we can do is add a little bit of a fill in here. So if I come over here and I draw a polygon, if I just draw from here up to there, so I can go from like here up to there, down to there, and that, we're just going to hit close outline. And now we have a triangular connection there. That's a more robust connection. Then we're going to say ground and ground are good. That guy's good. This guy, we're going to hit that. Now here's a big problem, right? So we can run all the way around on the top layer. Actually, I think that is what I'm going to do. So we're going to do right like this. We're going to run right in between these guys. We're going to come up out on the other side, so we get a little bit of a gap between there. And then we're going to run straight back in on this side. And then we're going to do the exact same thing, adding a polygon there, where we're going to just draw that, right click and hit close outline. And there we go. So now we've got measurement point from here across, from there across, and now we've got one that's going to be kind of ugly. The one that's going to be kind of ugly is this one, because this has to connect. If we hit X here, you can see it. It has to connect all the way over to here. And that is basically a run all the way around the whole board to there. Sure, we could do that, but do we really want to do that? I don't know. Right now, what I'm thinking is I'm going to go ahead and connect this V measure straight across to this V measure. I'm also going to connect this V measure straight across to, I haven't decided yet, but I think I'm going to connect this V measure right up to this V measure. So now all of these are networked together. You can see that. I want that to be kind of in between there for that. And at 100% aesthetic, no no reason why you have to do that. So anyways, once we do that, we're going to do this. Okay, now let's come over here. I'm not going to connect this up just yet because I'm not sure how I'm going to be chopping up the bottom of the board. So let's go ahead and connect up. This pin is the first one over here that needs to be connected to something. So, and that's great because that guy is going to be going up to right there and goes to there. And then from here, go to this one, and oh, look at that. We don't need, oh, we're going to go ahead and do this, and then straight across like that. Perfect. And then this guy on the opposite side, yeah, he's in a pretty good spot actually. So he's going to come down and away. And then we're going to come up in between and straight across to that. And then this last one over here is going to be coming out and away, down and around, and that should be fine. Okay, and I think I'm going to go ahead and just run this out and away, similar to what we've been doing in the other ones. This guy, I'll just delete that out. And that is, again, aesthetic because you'll be able to see these connections in here. So I'm going to go ahead and place in my polygons to clean these up. Grab this. This guy's good already. This. And in case you wonder, the reason for having these triangles is really just anytime you have a 90-degree corner, it's possible for the acid they use to etch to pool in those corners and cause it to get cut away extra. I really don't think in this board design it's going to make an enormous difference, but I'm doing it anyways for good practice and just to make it look nice. So we're going to come along and probably do that to these also. Let's go ahead and see. So this is ground. This is +5. See, I think I'm going to have +5 running for this whole top side of the board, and I might make the bottom plus bat. We'll see. We'll see how that goes. So let's go ahead and connect this guy right here. Where does he go? Oh, he goes to that resistor way over there. Interesting. Yeah, I think this one resistor needs to come over, but boy, that has a nice symmetry to it, doesn't it? Yeah, I'll tell you what, I'm going to stick with the symmetrical setup. And, oh, and that guy is slightly out of symmetry, actually. There's more gap here than there is here, so that's going to look a little weird. That's okay, though. I'm not too worried about this being perfect. It doesn't need to be absolutely perfect. I think we're going to just run this resistor right down here, and that resistor will be, so I'm wondering if I want this to be near the edge of the board. Let's go to a 50 mil grid. I'd like not to have anything drilled or drawn within 50 mil of the edge. So you can see this 9 volt is right on the edge of that 50 mil, which is perfect. This guy, if he was here, I'd be okay with it. I think I'm going to put him right here. And then that 680 is going to be, that's the assembly text. We're going to come over and grab the actual text and stick that right there. Ooh. I'm not a big fan of that. Let's move him up by 25 mil. Can we squeeze him up one tick? There we go. That does not look bad. That doesn't look bad at all. And it's going to be fine. So we're going to go back to 50 mil. Okay, great. So now we're going to just come to here. We're going to hit X from there. We're going to connect this guy, and then we're going to connect from here over to that guy. And that guy is going to connect to where else? Literally nowhere else. That's all just shorted together. Now that is our plus battery connection. So yep, we want to have that plus battery connection coming out. Basically, yep, he's going to be coming over this way. It's going to there. This also is going to be coming down to there. We're going to come straight out. I think straight out's actually best. If we do that, that's pretty good. So that's our plus battery being sent over here, and that's going to be divided down. That's ground right there. And this is plus battery, yeah. And that's parallel with this. This is, I think actually, I want this guy to come straight down like that. Yeah, that's perfect. I want these two to be shown as in parallel. This is my minus battery. Now that is going to be running relatively close to the edge of the board, but we're still not down to that 50 mil concern area. We're just going to go to there. Okay, and that's going to be perfectly fine there also. This guy, we're going to have the plus battery go into that. I think we might just go ahead and run a separate line there. Okay, so that 2N7000, this is the protection circuit, if you remember. Yeah, I need my 25 mil grid for that. Oh, even smaller than 25 mil? Let's do that. Okay, that's not bad. And that hooks to ground, and then these guys. So yeah, we're gonna have, I want to have the battery positive. So that is going to be from here. We're going to be running X from there to, oh no, what? Oh, that guy runs to, oh, and that, what? My net, okay, yeah. We've got a power net there. So we're going to do this. Run straight to there, of course. We're going to want that to run to there. Zoom in a little bit and we'll come back out like that. There you go, perfect. And then this battery is going to go to, I think we're going to come straight out this away. One more to there, great. So now C2's job is to eliminate noise on the input, which should be minimal, practically zero from a battery. Especially with this short of traces. So C2 is, in my opinion, a little redundant here, but I'm using it just because it is a good practice for an LDO to have an input capacitor. 0.1 microfarad helps eliminate noise, ringing, and add stability. It's all good for that device. The other end of it, we definitely need a capacitor on the other end, and they recommend a minimum of 2.2 microfarads. So we're going to be adding in this 2.2 microfarad over here. And that guy is just a little further away. I'm kind of tempted to bring him closer because this 2.2 microfarad's job is to slow things down, and he's not really there for filtering or stability. This one is here for stability. So I think we're going to be flip-flopping these guys. This one we're going to grab and slide him up here. Now I'm going to rotate them around so the negative is on the left. And I think we're going to be placing that. Let's go ahead and switch to 100 mil spacing, and we're going to be picking a spot for them based on my 100 mil spacing. Actually, I'd like to move it by that. There we go. So you can see I've kind of centered these two guys a little bit to the edge of that. I want this one to be a little bit off the edge of this, which is going to be fine. I'd like it to be kind of centered on that too, so we're going to actually go to a smaller grid. Let's go to 25 mil now. We're going to be going up to zoom in on these guys. I don't really like that this doesn't have, it's not on my grid. It bothers me. 12.5 mil. So now we're down to 12.5, but that's okay. That's why I got a 12.5 mil grid, is so that we could do this if we wanted to. I'm going to hit X on that, run them straight across there. This gets deleted. There we go. Then this guy, he's going to get rotated around as well. These are both 2.2 microfarad capacitors, C5 and 2.2 mic. Yep, there we go. So this goes on top. It's going to go there. This goes on top. One more click up. 2.2 microfarad right there at the bottom. 2.2 microfarad right at the bottom. 2.2 microfarad at the bottom and at the bottom. There we go. Actually, maybe one extra tick up for this one. Maybe one extra tick up there. Okay. Then we're going to go ahead and take that V measurement. Okay, so back to 25 mil tracks here. And we hit X there to run this guy up and over to there. He's good. Now you can see there's tracks right in there. We're going to put track right here. Okay, so we've got all that. This guy, yeah, ground is connecting to there. +5 is there. Ground's fine. We're connecting ground separately. That's going to be a totally separate thing. But you can see, so far I've connected 100% on the top layer of the board. And we're going to go take a look real quick at what the... we're going to go take a look at the 3D view just to see how it looks with these tracks running around. So we've got a lot of other stuff on the board, but this looks to be pretty clean, really. We've got our 2 ICs. We've got our tracks running out of it. They're all running up nicely to these LEDs. They're not too bad off. Although these all seem to have lines running straight out, and there's just one that has a line running kinked off to the side and then down. And I mean, electrically, that's fine. I'm going to go ahead and straighten that out because I like things to be matching as much as I can. So nothing wrong with that the way it was. And now we zoom in and just make sure there's no acute edge there, which there is not. Perfectly fine the way it is. And then we can go back to the 3D view and double check that everything looks okay. So now these guys all have nice straight lines. We've got our diodes labeled. We've got our text for the percentage up there. Our resistors are all labeled with values. Those are labeled. These are labeled. And at the bottom, we've got the diodes for the reverse. And yeah, I mean, I'm thinking this looks pretty good. I need to add a positive terminal indicator onto the 9-volt tester pad down here. So I'm going to do that. Now, I've got a couple different ways I could do that. I think I'm just going to put it right up here in this corner. So I'm just going to go to silk screen and I'm going to draw lines to make this plus. So I'm just going to do a plus like this. And then I'll go in and adjust the size of it. I think this line width should be more like, actually I kind of like the 24 mil, similar to the thickness of my tracks there. That's a pretty fat plus symbol to let people know. And then going around this edge, I mean, that's just an indicator to let you know where the battery size is and kind of the shape. I think that's going to be fine. I'm going to view and 3D viewer. You know, I actually prefer this to be a little smaller. Looking at it, I just like it like that. And then I'm thinking we just drop this down from 24 to maybe 16 mil. And I think that's going to be exactly how I want it to look. Yeah, I definitely like that better. It's not a requirement by any means. It's just something to look nice. But now I need to figure out how I'm going to connect these pieces that are not currently connected. So I've got, I believe, 2 on this end and 2 over here. And then I need to clean up these measurement tracks, add in the triangulations onto those. And I think this board is mostly done. Okay. So now let's take the furthest away one. So this one right here, that one seems to be the worst. Because this guy right here, if I press X on that, and oh yeah, I need to fix my width here. And okay, now if I run this around, I can probably get to there. Let's see if I can do it. We can run this all the way around the board, all the way around like that, and just run it to there. Boom. Now the other thing we're going to have here is that connects way over to here. So that is a big mess. I do not want to do that. I'm going to undo it. What I actually want to do is I want to run this on the bottom layer of the board. It's going to run transverse across all of these and then come over here and connect to this, because this resistor, oops, this resistor, I want to connect to that resistor. And you can see how much of a mess it would be to connect those two on the top layer. Now, you certainly can. Like this is not an impossible connection. If I did this right here, that would be a DC connection. That would be perfectly fine. But I don't particularly like it for my board. So, and then on top of that, I'm going to have to go to this one. And now I'm going to have to connect this guy over here also. And that's going to be a bit messy also. So let's do this. We're going to go ahead and go to the bottom layer of the board. So we're switching onto bottom layer by just clicking on the bottom layer up here. And I'm going to select that spot, hit X. And now this guy is going to be able to run up here away from everything. Oh, see if I can get him to do that. And then he's going to run straight across my board over here. And on the opposite side, we're going to be able to bring him to the top of the board. I'm going to hit V. Oh, V for, oh, apparently V is a quick switch between layers. I didn't know that. But I'm going to go grab a via, and we're going to place it right there. And I would like my track size to remain consistent. So this is going to be kind of an enormous via, but we're going to do the little d is the diameter, the via hole is the hole there. So the hole size is going to be 24. The via diameter is going to be 24 times 3, which is 72. So we hit OK on that. And now you can see the metal on that blue line is going to remain that blue size all the way around. So 24 mil all the way around there. It has a 24 mil hole. Again, that's a big hole. That's not something that's absolutely necessary. I'm just matching these things up here to make them look nice. And then we're going to run on the top layer over to here. So then the other thing we're going to do is we're going to come from the bottom layer using V to switch again, because I discovered that and I like it. I'm going to be taking from here, we're going to be running out underneath the board and straight up to there. And while I'm thinking about it, we're going to go ahead and make sure that that triangle is closed off there. Now that does produce a pretty significant cut in my ground plane, because if you imagine the bottom of the board here as being my ground plane, the whole bottom of the board is ground, then any signal that wants to get from this side of the board over to this side of the board is going to have to go around that giant track. There are ways to get around that, but I'm not sure if I really want to do them on this board because it's not really critical for this board. but you could stitch over this with ground. So you'd have ground running over the top, or you could have this jump over nets. So you could have it like split right here, go up to the top layer, go across little ways, then come back down so that there is a solid ground connection between here. And you could do that multiple times if you had to. That would be a pretty poor design, really, but I kind of got myself into a mess here because I put my resistors on the left and the right, which is going to look nicer in my opinion, but it is going to make it so you have to have at least one really long connection across like this. But that's okay. Let's go ahead and try to connect up this guy. So now we're going to connect this guy, and I believe he's also going to go best on the bottom layer. So what I'm going to do here is I'm just going to run him up in between here, around the bottom. And we're actually going to jump to the top layer right here. So we're going to come over and we're going to copy this via. We're going to paste them right here. And that via is going to automatically go to our new net here. And then we're going to hit X on there and come across to that. So then on the top layer, I'm going to use this to triangulate all of these. Any that I have not done that to yet. And go ahead and do that. And then we're going to have there, there, and there. There, there, and there. And there, there, and there. Okay. And we'll do basically the same thing over here. Okay. And then I'm just going to do X to there. That's going to fix that a little bit. I mean, absolutely not necessary. Yeah, we're just cleaning things up, making it look a little nicer. Alrighty. So, and I prefer this to be one tick. What are you doing? Why do I have so many different tracks here? X coming down to there, coming down to there we go, like that. Okay. Well, I think if I grab this via and slide them around, we can actually get that there. I want to have a little bit of a gap here and a gap underneath, so we're going to have that doubled up. Okay. Okay. Now, I believe the only thing that's not connected is ground now. Oh, what's this guy? Oh, no, he goes to the right place, going right there. No problem. Oh, and the +5. So +5 on the top, ground on the bottom. Okay. Oops. There we go. So what I'd like to do is we're now going to go to the front. I hit save on this guy. We're going to go on to the back of the board. Sorry, back of the board. So now we're going to put in our ground plane by going to the back of the board. I'm going to go ahead and switch to a 100 mil grid again. So I'm going to put this ground plane all the way around this thing. And I'm going to go over here to my tools. And you can see I have a rule area. I have a filled zone, a bunch of different things. Filled zone is what I want. So we're going to start in this top corner. And we're going to tell it that it's going to be a ground fill. Hit OK. And we're going to do this all the way to the bottom and over to there. and close that outline. Okay. And then we're going to do another one now on the top layer. We're going to do this. And now I'm going to do this with plus 5 volts. Hit OK. And you'll see I'm going to come down to the point where my 5 volts is generated. So you can see this is what's actually making the 5 volts. So I'm actually going to only come down to there. And then we're going to close that outline. And then I want to have from here, I want to have my positive battery, or maybe negative battery is better. Let's do negative battery. That's going to go to here, down to here, and over to there. Okay, and we're going to close that outline. Okay, so now if I do this, I realize we have a bit of a problem here because my battery minus area is overlapping. I don't want that to be overlapping, and I'm not sure how KiCAD handles that. So I'm just going to pull it 100 mil away, which will be fine. It's going to be perfectly fine there. Minus battery section here. We're just going to get rid of these. Get rid of that. There we go. That minus battery section is going to be connected. Okay, so we go to edit, and then we're going to do fill all zones. So now we can see what all is being filled in here. So my minus battery has 4 connections all the way around. Those are connected up to these, and those connect up to this MOSFET. And then that's going to come around all the way over here where it's going to flood fill across to hit R18. It fills this, which is nice. That's what I wanted to have, some copper behind that to make it look good. And then that's got a gap in there, so we're good. That's all pretty clean. That's just the negative terminal of the battery being flooded across there. Realistically, it only connects in 2 places, right here and right up there, but that's fine. Does not bother me at all to have that. Now, the other side, we have ground. You can see that blue ground connecting here. That's going to connect across everywhere. The other side, the plus 5 volts, I want to make sure that plus 5 volts is actually connecting to everything. So here we have this plus 5 volts going to this capacitor. It's going to here, and it connects into this interior area, which goes nowhere. Doesn't actually do anything for us. But that goes through these resistors. So you've got this kind of narrow spot here to connect to that. That is sufficient. I mean, we're going to be able to get power to our comparator from there, so that's not a big issue to me. Get ground there. These guys, so that's got 5, that's 5, 5, 5. Okay. And you can see the 5 volts is coming from this LDO regulator. So we have our positive battery terminal coming in from here. That's, of course, protected from this for reverse connections, but that's going to come up here and go to the capacitor. We've got from battery plus, it's going to go through to plus 5 volts, and that's what's generating this whole plane here. So that's going to be filling that. We've got pretty close to there, we've got this plus 5 volt C1 capacitor that's going to be helping us out with that. 5 volts for this guy comes from here, and that's also fed all the way around. See, we've got something that kind of bothers me here is our supply is right here, but in order to get voltage, the positive 5 volts, to the supply pin of this, it looks like they're close together, right? They're physically close together. But in order to electrically get here, you can't go straight across. Like, that's not a direct connection. You have to actually go around this way, all the way over here, all the way up here, all the way up there. Now this is a filled region here. Oh, nope, that doesn't make it. We got to actually go all the way up here, all the way around, all the way back down here, and that's where we're getting our 5 volts from. So I am going to just provide a direct path for 5 volts. I'm going to be placing a via right here and pulling 5 volts on the bottom layer across to that pin. So we're just going to go ahead and place in a via. which is going to be this via right here. We're just copy and paste that guy. Same size via. And then we're going to change that via's net. So this guy is a through via. Yeah, the net. See, I need to... Okay, yeah. So, but we need a... automatically update. Let's change this net to be forced to be 5 volts. There you go. And then that guy, we're going to hit V to go to the bottom layer, X, and run to there. So that's just a direct connection on the back of the board. It's going to allow me to hook these guys together. Now, I'd like to do the exact same thing right over here because I want this to also have a pretty decent connection to the 5 volts. But you can see that's even worse off because we've got this chopped out right here. There's no plane that goes in this direction, so that actually has to go quite a ways around to get to that. So I am going to do 2 things here. First, I'm going to switch to a 25 mil grid, so I don't have to go so far. But my plan here is to go ahead and just put a via right here. And place 5 volts right there. And I believe we're going to come around to right there. Should be okay. So let's just hit X, route it around to here. Boom. So that's going to provide a much more direct path for the 5 volts to get there. And that shouldn't cause major issues for my ground connections. I'm going to I'm going to save this, go to edit, and then we're going to fill all zones. I'm just telling it to update the fills to make sure that they don't overlap. So you can see that's now gapped out. So you can see now there's some clearance added in here that that wasn't there whenever I first drew that. So now I believe we have this board completely finished. So now at the top we have this little checklist with a check mark next to it, the design rules checker. And I'm going to run DRC to make sure that everything is doing what it's supposed to. And you can see I've got a bunch of warnings, which I'm not very worried about. These are things like silk screen isn't perfect. You know, like here you can see, I believe that's coming from, yeah, that arc right there is going to get cut a little bit because of the way that the footprint was made. It's not my footprint, but you know, it's fine. I'm not worried if that ends up losing a little bit of silkscreen there. Perfectly fine. But if we want to go and look through here, there's nothing else there. Now we see silkscreen overlap. Reference D11 is overlapping with something. So what is that? So we're going to go look at that. And yeah, I mean, technically true, D11 does hit the cathode indicator, but I don't really care. That's perfectly fine. So then we're going to go back to our DRC check, and I want to look at this error though. It says there's an error. Let's look at the error. It says thermal relief connection to zone incomplete. One spoke connected to isolated island. So we see that basically this is, it's saying that this little island in here is hooked up by this one connection, which essentially that becomes an antenna. It's not going anywhere. It's just going to be receiving or transmitting noise. Now, this is a DC connection, so absolutely not an issue with that existing there, but it's saying maybe we should eliminate that. I'm thinking about how I might be able to fix that, and one way that I could fix it is just to allow that to connect external. So I could pull this down, for example. Well, not that, but let's pull this down like this. So now I give a much wider berth there, and that will allow the 5-volt connection to run through. I can pull this up here, and that gives me a much better 5-volt connection into that area, coming from the top anyways. I'm still running my connection from the bottom, so it's not a bad connection. So let's go ahead and try this again. Go to Edit, and then Fill All Zones. And we can see now that that floods through all there. And then I'm going to hit, go to my DRC again, and we're going to delete all markers and then rerun our DRC. I'm back to only having warnings there, so I'm perfectly happy with that. There is no reason to worry about this. I think for this one, I'm going to tell it to not delete the islands. And we're going to refill it. So now, and that's only because I'd like to see that copper there, because that copper is not going to do anything for me. It's just going to look nice. And that's it. And we'll see a little bit of a gap on the board here. So let's go to View in 3D Viewer. And now you can see what the final version of the board is going to look like. So we're able to clearly see that the positive side of the battery goes to a couple of places. It goes here to this reverse LED, and it's also going to go up to the rest of the board. And then we're going to have it run across to these resistors right here where it gets divided down. I am really tempted to move these resistors down here. Those are not part of the measurement circuit. These 4 and these 5 are part of the measurement circuit. These are all part of the LED driver circuits up there. Question is, do I care? That's all flooded with 5. This is flooded with negative battery, so basically ground. Ground is flooded on the back. Let's go to the back and look at this guy. So on the back, you can see, from here you can see how much my ground is going to be cut up by these traces. So if I had a signal at the bottom of the board and it had to go to the top of the board, it's going to have to go around this, or all the way around that. But again, DC board, not a big issue. We could absolutely clean that up, but I don't think we're going to run into any problems at all here. This is just a little battery tester board. It'll look cool. I like how spaced out everything is. Realistically, I could make it all closer together, but I think part of being a beginner level hobby board is you want it to be spaced out, so it's going to be easy for people to solder it. That's actually one of the purposes of this board, is to make it easy to solder. And you can see my W is shining through with the copper underneath. We'll be able to see that. And the 9-volt tester points here, you could put some solder on those to make them a little bit more resilient. And that's probably what I'm going to do actually in my version. But yeah, that's going to be it. I think this board is 100% done and ready to be built and tested out. If you've made it all the way to the end of this series, I would like to say thank you very much for watching. I wish you luck with making your own 9-volt battery tester, and I hope that you have a great day.